Perfect.
Okay. All right, thank you guys. Let's get into the presentation. So what I can see is that we have about 10 people that describe themselves as BI developers or business analysts, so you are the perfect audience. From a BI experience point of view, we've got a range from 1 to 10. I do like at this stage to use the feature of Q&A and to ask the question, you know, what is the average rating? Whereupon we could see the average Power BI experience for the audience today is 4.27. I'm going to pin that back to the dashboard, and then that could be monitored as well. All right, let's get into what matters for this presentation, and that's working with Power BI model relationships. And my intention is to cover everything to do with Power BI model relationships and to share with you, good guidance and design practices. So the best place to begin, I think, is to look at an example of bad modeling. All right, what I have here is a Power BI desktop report. It consists of a single table. And what I would do is describe that this is a bad model because we have a single table. And you'll find that you have fields that belong to, category, sounds like something to do with product, email, first name, last name, something to do with a person. And so therefore it's very difficult for a report author to actually understand what this model represents. It's easier when in the fields pane, which you see here on the right, it's easier when they can see the fields grouped by table, and that they might see a product table and a manager table and so on. So report authors find this more difficult to understand and therefore build reports. The other topic, though, is that from a performance point of view, and especially as the data volumes in your model grow, it becomes inefficient to have a single flat table like this. And lastly, if you were to build up calculations in the model using the formula language of DAX, data analysis expressions, you might find that this design works well against you because in certain functions you need to work at table level, remove filters from columns within a particular table. And therefore you're going to have to write much more complex and probably less efficient formulas to achieve what you need. So let's just begin by saying it's generally not a good practice to create a single table model. I will say that there are some exceptions. For example, it's a data exploration task or a proof of concept. But from a point of view of producing a model that you expect to be used by other report authors to have longevity, that you'll maintain it and report from it for many years to come, do not begin with this design. So that brings us to, well, what are Power BI model relationships? And they matter when your model consists of more than one table. Now, by definition, model relationships propagate filter context to other model tables. Let's take a look by example. Let's just imagine a fairly simplistic model here that has a sales table and it has a product key and a year and a quantity. In the same model, there's the product table, and each product is defined here with the product key, name, category, and color. In the model, there's also a relationship that relates the two tables, noting that the product is a one side and the sales table is a many side. We'll talk about cardinality shortly. But let's imagine that you ask a question. Now, this could be a visual on your report page, showing the number of sales quantity for product B. Well, what happens is that a filter is applied to the product table and the relationship propagates that filter. The sales table has 3 sales rows for that product. The sum of their quantities comes to 17. Now consider if there were 3 tables, the category with a relationship to product and product with a relationship to sales. And this time the question is, what is the sales quantity for category A? Well, watch the animation. There are 2 products for category A, and for the sales of those products, there were 2. The quantity is 14. One more example, this time introducing the year table. And so the question is, the sales quantity for category A in 2018, watch the animations and notice that the filter from year to sales reveals that there's just one row in the sales table where the conditions are true, that it's a product from category A and it's a sale that took place in 2018. So relationships propagate filters from tables to other tables, and a good model design should strive to deliver the right number of tables with the right relationships in place. Now, that's a challenging discussion because the right number could mean many different things. And experience over time will tell you what is the best number of tables and relationships. But what we find very helpful in guiding Power BI data modelers is the theory of star schema design. Now, this design concept is for relational data warehousing, and you might be familiar with the classification of tables being either dimension tables or fact tables. Well, while Power BI doesn't have a concept of a dimension table or a fact table, learning star schema design and then using it to produce an optimized, efficient, and intuitive model is very important. All right, the next point I'll make before getting into deeper theory is that relationships in your model are not concerned with referential integrity. You see, in a relational database, and especially when looking at a diagram of tables in that database, you'll see connectors between tables. And for a relational database, those connectors are in fact foreign key constraints. They're enforcing referential integrity. For example, you cannot sell a product that hasn't been defined in the product table, and it works the other way. You cannot delete a product if it's been sold. So this is a very important concept for the integrity of your data, but in Power BI, this is not what those connectors mean. They're actually there as filter propagation paths. They are not concerned with integrity. Secondly, when it comes to relationship design, it can be considered part science and part art. All right. What I mean by this is there can be sometimes multiple ways to achieve the same result. Different tables with columns, different granularities, different relationships. You can still achieve the right result, and there isn't perhaps just one way to do it. And so therefore, it's a blend of good science, as in achieving the right result based on what Power BI relationships do, and then adding a bit of art and elegance sometimes to your design is part of the mix. So just making it clear that there might be multiple ways to achieve the same result, but usually you'll find that there is one that fits best for your purpose and for optimization. Now, a little bit more on star schema. Why is it called star schema? Because at the center, we have a type of table known as a fact table. And the fact table is used to store transactions or observations. In this case, they would be sales orders for the resellers at the AdventureWorks company. Now, what forms the star is that we have dimension tables, and if you use your imagination, these dimension tables are like the points of the star. And these represent the business entities that we're modeling, like products and resellers, employees, and even date or time itself. So what we ask you to do is that when you're modeling in Power BI, we ask you to think about the entities that you're modeling, and therefore to design tables to reflect those. You see, dimension tables define things like date, product, people, places, and concepts. They're characterized by having a unique column so that we can uniquely identify every row in the dimension table. Typically, they contain a relatively small number of rows. Like, it's unusual that your company would have millions of products, but you might have millions of sales of those products. These dimension tables then, when it comes to reporting, are used to apply filters or grouping on. Now, the fact tables, these store observations or events like sales orders. They include the dimension key columns and numeric measure columns like quantities and sale amounts. They can, in contrast to dimension tables, contain a very large number of rows. And the purpose of these is that at reporting time, the measures or the row counts are used as summarizations of fact data. All right, so notice I'm highlighting here filter, group, summarize. That's what every report visual does. It filters, it possibly groups, and then it achieves some summarization. And then using some graphical representation like a column chart, pie chart, or map visual is how we then convey that result to our human report consumers. All right, so this slide just compares the two. At the end of the presentation, you'll have a link that you can use to download this presentation because it has a lot of good practices that you might benefit from in your own projects. So I'm not going to read through this. I'm going to move straight into the Power BI objects now. So when it comes to a Power BI model, and we should be clear that when the model is published to the Power BI service, it's then called a data set. So whether you call it a data set or a model, for our purposes today, they're much the same thing. But characteristic of the models in Power BI is that they are tabular. The top level object within the model is a table consisting of columns, and of course we import rows into these tables. Now the properties you have for a table, they're quite there's just a few of them, like the unique name, the storage mode, whether the data is imported, or if it's a direct query table, it says that the data remains in the data source, and then Power BI will query the data source when the reports are queried. Now it's also possible that your table is a dual. It is both an import and a direct query, and that happens when you have a composite model. All right, so there's really three types of models. The most common is an import model, whereupon data is imported into the tables and you have typically a recurring schedule that refreshes and keeps that model data up to date. Direct query is the opposite. The data is never loaded into the model. It's stored in the source, and as Power BI needs to query it, it uses a query against the source system. Now, the big benefits of direct query is that if you have extremely large volumes of data or a need for real-time results coming from your data source. Now, composite, just to bring it into the picture, is where you can have import and direct query at the same time in the same model. A bit more to discuss on that later because it does impact on how relationships are evaluated. Now, the property on a table called table role, is it dimensional fact? I'm making that up. You know, I've just introduced to you that there is a star schema design approach used for relational data warehouses, and a lot of this theory is applicable to Power BI, but there is no such property on a table to declare the role, whether it's dimensional fact. Let's come to the next object in the model, that we have tables with columns, and where we have more than one table, we need to consider relationships that will propagate filters between tables. So let's be clear by definition that a relationship is one column in a table with a filter propagation to another column in a different table. All right, so it's always from one table to another. It's always one column to another single column. And it's not possible to have relationships relate back to the same table. Not to be confused that foreign key constraints can do this. Typically on an employee table that you might have your reports to employee, like the boss. Yes, you can have a foreign key constraint that enforces self-referencing integrity, but not for filter propagation. Now, the properties of relationships, the main one is the cardinality. Is it one to many? Is it many to one? Is it one to one? Or is it many to many? Now, I think I asked you a question about this, so let's take a look. What I wanted to have a look at let me use Q&A to say session question. What was of interest to you today? So no, not doing what I wanted to do. Let's come back here. Of interest to you, the largest group are interested in many-to-many. With the next, and we're coming to the topic of weak relationships and strong relationships shortly. The one-to-many relationships are the most common type that I'm about to introduce, and one-to-one, we can use them from time to time. Apologies for anyone looking for romantic relationships. I've included that there more for fun, but that will be a different meetup that you'll need to go and visit. All right, so of interest to you is that we have this many-to-many relationship, or rather, it's a many-to-many cardinality. So I'm going to describe all of the cardinalities tonight, of which here are the 4. Filter direction is another property. Does it filter in one direction or does it go backwards as well? And if you're using row level permissions and you have a bidirectional filter, will the row level permissions also use both directions? It's also possible to have relationships as inactive. And the last property, assume referential integrity, applies to DirectQuery only. It says that if Power BI needs to join multiple tables together, should it use inner or left joins? If you say assume referential integrity, Power BI will use an inner join, which is more efficient. But of course, an inner join has the problem that if there's a lack of integrity, mismatches will be excluded from the result. So you need to be very careful. If you know that integrity is in place, then we recommend for direct query models that you use this property. Okay, lastly, only one active path can exist between 2 tables. And I'll come back to that in demo very shortly. Now, I mentioned the table role earlier. Was the table a fact table or a dimension table? While there is no explicit property that classifies a table into either role, it is in fact the cardinality that determines whether the table behaves as a dimension or a fact. Let's see why. Here in this diagram, we see the star, we see the fact table in the center, and dimension tables around the point. The classic pattern that we recommend is that you're going to use one-to-many relationships from dimension to fact. Think about it. In a dimension table for our products, we define them once with a unique identifier, and then in the corresponding fact table, we would expect to sell that product multiple times. So this is a classic design pattern that often achieves the most optimal result for Power BI models. So note that a fact table can be identified that it is the many side of the relationships, and the dimension tables are the one side. Next topic. Now, this presentation gets a lot of theory out of the way, and then I'm going to come back to a big demonstration that covers most of what I've introduced here. So the next topic comes down to the evaluation of relationships, of which they're either strong or weak. This is not a configurable property. It's actually inferred from cardinality type and also the data source of the related tables. The evaluation type can impact on performance, and also there could be integrity issues that might cause problems in your report. Let me explain. So the strong relationships are the good ones. It means that Power BI can determine that there is a one side to the relationship. So in a one-to-many relationship or a many-to-one relationship, and even a one-to-one relationship, these relationships are strong providing that the model is an import model or a direct query model. Okay, so it might be easier to explain what this means and why. Let's take a look at this example again of the 3 tables related from category to product to sales. And what happens if you're querying category and sales at the same time in the visual? What Power BI does is it creates this query time expanded table. You can, in a way, think of it as a denormalized set of data, but be careful, it's not actually materialized. But this is the way that Power BI understands what related table values are on a row basis. This makes perfect sense so far, but consider that a new row was just added to the sales table for a product that does not exist in the product table. What does this mean? Well, notice that the expanded table does this. You can think of it that the category to product is a left outer join. Product to sales is like a left outer join. And so this is a characteristic of a strong relationship, is that if there is a lack of integrity, the blanks will be added. In fact, a blank row is added to the product and the category table. For those of you that may have noticed that sometimes in a report that a slicer is presenting a blank option for filtering, and yet you're pretty sure that there is no blank in the table or the column that the slicer is based on. There's an example that there's probably a lack of integrity where Power BI is compensating by adding a blank row to the table that your slicer is based on. This is a good story because it means you can also ask the question, what were the sales for products that we haven't defined? With a strong relationship, that will be possible. Now, a weak relationship is where there is no guaranteed one side, and it can only happen for two reasons. That your relationship is using the many-to-many cardinality type, okay, or the relationship is what we call cross-island. This will only happen in a composite model where you have mixes of data sources. All right, in a composite model, you could have an import table and a DirectQuery table, or you could have multiple DirectQuery sources in the same model. Now, when a relationship spans across import to DirectQuery or between two different DirectQuery sources, then that relationship will be weak. Let's see by example. Consider this to be a model of 5 tables, yet 3 of them are import and 2 of the tables are sourced from a single DirectQuery data source. Well, where are the strong relationships? Certainly the one-to-many relationships within the islands are strong. Yet many-to-many or cross-island relationships are weak. And what we must be very aware of is that when we have weak relationships, is that if there are data integrity issues, we will not get blank rows compensating. You can think of it as doing an inner join, and it would eliminate where there are mismatches on either side. All right. So this is just a consequence of using many-to-many cardinality or using cross-island relationships. The last piece of theory before I move into demonstration is that there are a series of functions in DAX that work with relationships. The related and related table functions, the use relationship function to force the use of a specific relationship, cross-filter allowing the modification of filter direction or even disabling a relationship for the purpose of the evaluation of your expression. There's the treat as function that can be used to, in a sense, create new relationships virtually for the purpose of a calculation. And then lastly, the path functions. In fact, there are a family of functions that help you naturalize a recursive parent-child relationship that you might have in your source data. For example, again, employees. There's a relationship to the employee of their boss. Okay, we won't cover path functions, but for completeness, these are the DAX functions that are concerned with the relationships in your model. All right, so I'm just about to apply a lot of this theory through a model, through a demo that I call good modeling. Now might be a good time to give me some feedback as to the clarity of the audio and whether all is good from your side.
So I'm checking right now, Peter. We can hear you. Mm-hmm. We can hear you very well, very clear.
Okay. Well, as we're checking, I'm going to launch Power BI Desktop because we're going to create a whole new model, and I'm going to build up your knowledge through demonstration.
Fantastic.
All right, so while Power BI Desktop is opening, let me introduce you to the sales data that I'm about to model. Note the characteristics of this data is that we have a region for the sale, we have the order and ship date. We have a stock keeping unit, that is a unique identifier for a product. We have the ID of the manager that's sold. We have the quantity and the sale price. So now that I've launched Power BI Desktop, let me go ahead and get data, and I'm going to connect to that Excel source. Having connected to the source, I find the data is here, and I click Transform Data because I understand that I need to create a new column, and that new column is going to multiply sale quantity by sale price. So on the Add Column Ribbon tab, I just perform a multiplication, and then I rename this column as the sale amount. Okay, so that commences my first table, yet I have other sources of data. So I'm going to go ahead and import some data from a CSV file. In fact, what we'll find is that the product definitions are stored in CSV. And it's very simplistic data. This company just has the 4 products. We'll notice that row 1 is in fact the column headers. So there's a transformation on the ribbon that allows me to use the first row as headers. All right. Each product has a stock keeping unit, it has a name, and it belongs to a subcategory. Now we have categories as well, but it's interesting to note that they're stored in a different source that is an Excel workbook. So I go ahead and I open up subcategory. Very simplistic, the subcategories are assigned to category. But wait, there's more. So in another Excel spreadsheet, each product has its list price recorded. Now you can imagine that perhaps the sales or marketing people control this document, that for each stock keeping unit, they have the current price. So now I've got 4 queries, but I have one more. And that the managers responsible for the sales are actually stored in a CSV file. Of which we just have the 2 managers. Now, take a moment just to understand this data. The first column is the region of the manager, and then we have the manager ID. But it's interesting, is it not, that each of the managers has the same ID. So in fact, we would regard this to be a composite key, that it's the region and manager ID together that uniquely identify or record the manager. We have their first name and their last name. We have an email address. And then interesting again is that subcategory here. It's interesting for 2 reasons. That subcategory isn't a natural attribute of a manager. And the second value there is in fact a delimited value. It's 2 subcategories, hot beverages and snacks. And so what I'll describe to you is that the managers at this company, not only are they responsible for sales, column A and column E in the sale data is the way that we can achieve a lookup or an understanding of who the exact manager is. But these people are also responsible and measured by the sales of different subcategories. So there's 2 concepts here. A manager is responsible for an individual sale, but a manager is also responsible for the sales of 1 or more subcategories of products. Okay, so what I'm going to do here is I'm going to rename that query to become the raw manager, because I understand that this is the raw data, but in Power Query, I'm going to reference that query and create the manager query that my model needs. I will do this by removing subcategory. And I'll also merge together these 2 columns, merge columns. So I've just got a unique space separated manager column. All right, so we've got region, manager ID, the manager themselves, and email. Now, switching back to Power BI Desktop then, these are just queries, they've not yet been applied. So I'm going to switch to modeling view and I'm going to apply those changes, whereupon Power Query then imports the data into the model. As a result of this, we should end up with various tables. Now, this is not what I wanted to happen because I have left the relationship properties on. So excuse me while I click and right-click every relationship and delete them. That is my mistake. And let me explain why. That there are data load properties that auto-detect relationships, and I forgot to turn them off. And so I'm going to show you how I would have done that, but in the meantime, let me just remove them all, because I'd rather explain how to create them than to just show you that they can be automatically created. All right. So what I was supposed to do, but overlooked it, was come to the options and settings. And for this Power BI file, under the data load that you see down here, is that there are these properties that are concerned with auto detection or creating relationships on the first load. All right, you might choose to leave these on. For demonstration purposes, I'm going to turn them off, and I should have turned them off earlier, so that we can discuss and manually create those relationships. And while I'm here, I'm also going to turn off the time intelligence. This property will create hidden tables for me for date time. For today, I don't want that. All right, so having adjusted those properties, the next thing is I like to lay this out so it looks a bit like a star. You know, we've got subcategory here, we've got product here, we've got list price here, we've got manager, and I've got raw manager. Well, hold on. I didn't intend to load raw manager, so I come back here and I disable the load. I get a warning that it will remove the table from the model, and I apply changes, and yes, I do not want the raw data loaded. Okay, so the schema is starting to look like a star, but there's a table missing that really is critical for most model designs. And because we have order date and ship date in the sale table, we really need a date table that's going to allow us to filter or group by different time periods, maybe year, quarter, month. And the approach that I'll take today is to go ahead and create a new table. And I'm doing this on the model ribbon tab. That by using DAX, an expression like this, that my table name date is in fact calendar auto. And what calendar auto does, as you can now see, is it produces a single column date table. Have a look in the bottom right. We can see here that the date table has 365 rows and 365 distinct values. What auto has done, it has looked at the columns in the model that are of type date or time, and it has determined the min and max of all of those dates. And then it has produced a single column table that spans those dates by using full years. You see, calendar auto has no arguments passed in, which means that December is the end of the year, but I could have passed in 6, that June is the last month of my year, and then this expression will automatically produce a table of a full or complete years spanning every date that has already been loaded. This is a very easy way to create the date table. Now what I'll do next is I'll come in and I will create a new column. Because I know that I need to filter or group by years, well then I'll create a column like this. Year is calendar year, and whatever the whole number is for the year itself. All right, so take a look. The literal text CY concatenate the year of the date, and then we end up with this column here. Let me do one more, and that is that I need a month column. And I will use a DAX function named format. Format the date as YYYY-MM. If you read the documentation for this function, you'll learn that the lowercase y is year and the capital M is month number. So now I have year and month. Now that calculated table is here. So your tables in a model either come from Power Query or they come from a DAX expression. So our star, if we can use our imagination, is sort of taking place. But let's put it to the test. Noting that there are no relationships in the model, I'm going to use the report to test it. Let me introduce month from my date table, and then from the sale table, let me bring in the sale amount. And when you see a result that looks like this, you need to be suspicious, right? That every month is the same amount and the total. When you see this symptom, it's likely that you don't have a relationship or the relationship is there but not correctly configured. Obviously, we can see in the model diagram that there are no connectors between tables. So the way that I'll fix it for this first part of the demo is on the modeling ribbon, I will manage relationships, and I'll manually create the relationship by relating the date table to the sale table, and that the date relates to the order date column. Now I'm getting an error here, this circular dependency. I think this is a bug in Power BI Desktop, because if I do it the other way around and I join sale to date from order date to date, we don't have a problem. But what we'll note then is that the cardinality is set for us and the relationship's active. And for the moment, I'm just going to accept those defaults and click OK, click Close now that I have the relationship defined. And then what we do is we verify that the visual is making sense. So based on the different 3 months of 2019, these are the sale amounts. All right, do notice in the model diagram then that I have a relationship between the date and sales table. Now, the other way to create relationships, and the faster way, is just to drag and drop column to column, subcategory to subcategory, SKU to SKU, and SKU to the sale SKU. And now I come to relate manager, and I have a dilemma. You know, I can relate manager ID to manager ID, but first of all, we get a weird warning here telling us that this is going to be a many-to-many arrangement. And as we'll discuss later, you need to be on guard. That's a pretty serious warning. But what we should understand, though, is that manager 1 from North region is different to manager 1 to South region. And so the issue we have here is that we require creating a relationship based on 2 columns, like manager and their region and manager ID to manager ID and region. Now, it is not possible to do this in a Power BI relationship. This forces us to return to the query editor, whereupon when I come to manager, I'm going to create a new column that in star schema design we would call a surrogate key. On the Add Column ribbon tab, I can introduce an index column starting from 1. I'll rename it as Manager Key. I'll switch its data type to become whole number. And then I'll just move Manager Key to the front. Now in the sale query then, I'm going to have to introduce Manager Key by, and here in the combined group on the ribbon, I can merge queries, merging sale to my manager. And while pressing the control key, watch what happens. I click region, then manager ID. So notice that order matters, that a multi-selection of columns matches region to manager ID. So don't be confused. This is not a model relationship. This is Power Query achieving an integration of 2 queries based on 2 columns. That introduces a new table that I can then expand to introduce the manager key into my sale query. I'm going to push manager key to here, and then I'm going to remove the region and manager ID. So now that I've modified 2 Power Queries, I can switch back to Power BI Desktop. I can apply the changes. And now I have a manager key to manager key that I can use to relate the tables. Okay, so at this stage, we could describe that a star is born. We have the right tables, we have relationships in place, but we're just about to discover there could be other problems. So let's have a look. Let me introduce more sales data. It just so happens that on the April 4, we make another similar sale. And I save this source data, come back to Power BI Desktop, and then I'm going to refresh the data for the sale table. Whereupon we see an error. Let's read this. Column SKU from the sales table contains a duplicate value for this result. And here is the problem. If we look at the relationship between product and sale, relating the SKU columns, interpreting the diagram, we see that we in fact have a one-to-one relationship. And remember, the pattern is this, that the fact table, in this case the sale table, should have the many side. To edit the relationship, you simply double-click it in the designer. And it's the cardinality property here that from product to sale should be one to many. I'm also going to update the cross-filter direction. I'll talk about it shortly, but make it single. That was the problem. And the problem is that when you create a relationship by drag dropping or using auto detect, Power BI looks at the cardinality of the values in the column. If a column is unique, it assumes it's a one side. And it just so happened that the original sales data, it was unique for the stock keeping unit for the first 3 rows. All right, let me see that the other relationships, we've got one to many here, one to many here. Here we have a one-to-one. And this is a valid relationship. Remember, marketing have a list of every product and they then describe its list price. Manager to sale is one to many, and date to sale, again, one to one. Let's go ahead and modify this cardinality that from sale to date, it's actually many to one. Now, this is the pattern that we want you to adopt, reminding you of these many relationships sitting here around the sale table. Okay, well, now that we've got the right tables and columns and relationships correctly configured, let's explore what we can do with calculations. So coming to the sale table, what I could do is create a new column that would tell me the category of each sale. And I can do this because of relationships. I can use the related function. That in the subcategory table, just go and get me the value for the category column. And now I've added a new column to sale. And when you think about it, that related did this. It jumped here from the many to one and here from the many to one. This is an example of table expansion. That related is using table expansion to retrieve the values in related columns. Well, we can do it the other way as well. This time, let me go to the subcategory table. And the opposite of the related function is the related table function that allows you to navigate in the many direction of relationship. Okay, so a new column that I'll add here will be called sale orders equals related table sale. Now, related table returns a table, and therefore we can't return that in a column, but we can summarize it by counting the rows. In other words, how many sales have we made for each of the subcategories? All right, 2 for beverages, 1 for food. All right, now, having demonstrated this to you, I would recommend you don't do it. This is something that at query time, that your visuals could do for you. We don't need to persist and materialize these values, but know that these functions exist. So what I will do is delete them and then show you an example of a real world function that would work. Okay, so don't do this because we can just group and filter and summarize anyway. But the example that I'll give you is that we would like to know if any discount was applied to a sale, and if so, how much. So what we do know is that we've got a sale price and a sale amount and a quantity. But remember that the product list price tells us what we should have charged. So theoretically, if we can take the product list price, multiply by quantity, subtract the sale amount that we achieved, any difference has to be a discount applied. So let me build up this as a new column, which would be called discount amount. So I will then ask for the related product list price multiplied by, in the sale table, the sale quantity, and then I'll subtract the value in the sale amount column. And what we can see then is that there's just the one product, or rather one row in the sale table that must have had a 40-cent discount applied. Okay, so there's a good real-world use in my discount amount column of using the related function. Alrighty, so what we've produced is at the point where it works, but arguably this is not an optimal design, and let's understand why. So the first thing that I would like to address is that a one-to-one relationship is really just an extension in this case, that for each row in the product table, we really have a new column called list price. The fact is that they came from different sources. One was Excel, one was CSV. But we would recommend that where you have this one-to-one relationship, instead of modeling it that way, you could come to your Power Query for product and you could just integrate at this level. Let's integrate the product list price where there's a match on stock keeping unit, and then we'll introduce the list price into this query. And therefore, I can disable this query, and as a result of this, I'm decluttering the model. There's now one less table. Okay, and I know what Power BI Desktop here is got another bug. So let me just save the solution. The bug is that the model designer has just ghosted out on me, right? And I know the only way to fix this is to save everything, close and reopen. But while I'm closing and reopening, what I've just achieved there is the reduction of one table. And now our product table has the list price column. So my point about this is it's probably better to integrate and put them in a single table where people would expect to find it. They don't expect to find list price in a separate product type table. All right, so here's the product table and there's the list price for it. Now, by the way, that will have broken a formula. My discount amount is now broken because it's still looking for the list price in the product list price table. So what I'll do is I'll just fix that so it's now looking for that column in the product table and it works again. My guidance around this is that you shouldn't start writing formulas until the foundations of your model, and by foundations of the model, I mean tables, columns, and relationships are firmly in place. Now, back to the diagram, having subcategory and product is just another example where the columns in the subcategory table are really just attributes of product. So let's do the same thing. Let me go ahead and transform the data by merging the subcategory query into product. That based on subcategory matches, we can bring the category into this table. And then I can disable the load of subcategory. And what were 3 tables describing product is now just one. Much easier for a user to understand, and we have the ability to do this. I can now create a hierarchy, and this will be named my products, that will have the levels of category, subcategory, and product. It's not possible to create a hierarchy when the columns are in different tables. All right, so an added benefit of this design is that we've now got a single hierarchy which just facilitates authoring reports, but it also makes it clearer to those when they're looking at the fields pane that, aha, there's a hierarchy here for navigation from category to subcategory to product. And sometimes if you don't declare these hierarchies and add them in your model, users overlook their ability to work with visuals like, drill down behaviors on matrices and other charts. Okay, so there's an added benefit. So the model is looking now a little bit neater. But let's now take a closer look at the relationship between date and sale, because by hovering over the relationship, we see that it is in fact relating from date to the order date in sale, and yet we also record ship date. So let's create a second relationship from date to ship date. which we can do, but as I mentioned earlier, there can only be one active path between two tables, that filter propagation has to be deterministic. So what you now see as a dashed line indicates that it is a relationship, yet it's inactive. And that's controlled through the property that you see here. Let's take a closer look through an example and a visual. All right, so what we see at the moment is monthly sales. When I come to the modeling ribbon and manage relationships, we will see that the relationship between sale and date is based on order date. So what you're really looking at is, what were the sale amounts based on order date? But what you can do is toggle the active to inactive for those relationships, and then see that we get a different result now, that January is no longer a grouping because we didn't ship anything in January, but here's the result of sales by shipment month. Now I'm going to just switch that back now that you know how it works. But generally speaking, having inactive relationships can be problematic in your design. Because what it means is that we cannot simultaneously filter by ship date and order date at the same time. And sometimes you have a requirement for that. So this is how we might address it. I'm going to create a new table. The new table will be named ship date, and it will simply equal the date table. In effect, I've just cloned a table. That ship date is whatever the date table is. What I will do is rename the columns. I strongly recommend that if you're going to create this type of table that is a different role of date, then provide unique columns so that your visuals and their labels become self-descriptive. And now you'll see that we've got these two date tables. All right, so I can then create an active relationship between ship date and ship date. But what I'll demo is this, actually. Let me just delete that relationship. There was something I'd like to show you. The relationship doesn't exist yet, that what you can do with inactive relationships, they can only be used if your calculation expression explicitly requests it. So what I can do using a snippet is that I can create this measure called sale shipped. Let me add it and I'll describe it to you. What sales shipped is doing is this. Using the calculate function, we use this function to modify filter context or to use functions like use relationship. So by calculating the sum of sales amount, but using a specific relationship, in this case, between the date and the ship date column, we're now getting the result that we see here in this measure. Now, the problem with this approach, though, when you're using inactive relationships, is that you have to create these expressions. And there could be, 15 different sale expressions, like year to date, year on year. It becomes challenging. So what I've just gone ahead and done was created a different table, create an active relationship. And you can have both at the same time. This would allow me to create a visual like this. Creating a stacked column chart, I could put the month on the axes and from ship month on the legend, and then I could put the sale amount in the value. All right, so now what we're looking at is the blue here for January and February means it was shipped in February. And to make this a little more interesting, what if I came in here and created another order and then refresh the data? Let's make it even more interesting. It was ordered in May. Sorry, it was ordered in April, but shipped in May. Okay, Power BI Desktop just crashed. And I probably didn't save my changes. Let's see what's happened.
I'm sure that's never happened to any of us.
Normally get a bit more warning. That's unusual. It didn't even warn or give an error. It just died. I don't know where I left off on the previous demo, so let's hope that I haven't lost much. Oh no. No. All right, I'm gonna have to quickly just catch up some things here. I won't repeat ship date because I won't have time, but what I'll quickly do is get subcategory and product integrated again, and I will pay closer attention to saving more frequently. All right, so what I'll do is just quickly integrate these.
Okay, go ahead. And in the meantime, just for the people who are online, we're going to be putting together a whole series of additional online meetings. And if you've got particular topics or speakers who you are interested in, let me know, because I probably know many of them, many of the potential speakers, and I can leverage that and get you the topics you're looking for. Just let me know, mark@designmind.com, and I'll try to follow up. I also, while Peter's working on that, I also will be providing a link so you can download the recording of this presentation. I'm not sure exactly how to do it yet. Nina is who's online is an expert in this, and she's giving me pointers in the chat session, and I'll work it out and figure out how to get the word out. Thank you.
Okay, well, I'm back on track. I'm not going to repeat the ship date because time doesn't permit, but you've seen how it works. The general takeaway is this: probably avoid inactive relationships unless you know it's just a few calculations that you're going to have to adjust by using the use relationship function. If you expect to simultaneously filter or group by date and ship date and delivery date and order, then you should have duplicate dimension tables in your model. Now, where I'm going to head now is into some more interesting territory, which involves importing some new data. You see, the company also has sale targets that it needs to achieve. And the sale targets you'll see are interesting because, and as is typical for budgets and forecasts, is that you've got higher level granularity data. Like, we don't target on a daily basis for each individual product, but we do it month level at subcategory level. Okay, so what I'm going to do is go ahead and apply changes here and bring the sale target in. And what's interesting about this, as I Control S to save my work, is that we don't now have the ability to create a one-to-many relationship between subcategory and subcategory. Because think of this, there are duplicate subcategories in sale target that is common for a fact table, but in product, because subcategory is a higher level, let's have a look, then we have duplicates like hot beverages twice and snacks twice. So the challenge we've got is that the fact table is at a higher level of granularity than the product table. Well, how are we going to solve this? Well, let's first of all create a relationship between date and month. And you'll note that this is just a standard one-to-many relationship. Why is it this? Because if we look at sale target, that this is just a date column. All right, you can see the data type here is date. All right, but we want to be very careful in reporting, because what you'll see the pattern is that for a monthly target, it uses the first date of the month. January 1, February 1, March 1, etc. And if you were to visualize this and you were to put date on the axes of a chart and literally interpret it, it would say, oh, for cold beverages, you must sell 110 on January 1. Hey, everybody, but you can take a vacation for the rest of the month because there's no expectation to sell on the other dates. Now, of course, that's not the reality. That 110 is a monthly level or a higher level value. But we can still create a one-to-many. We just want to be careful that we only use year or month when we relate to sale target. Now, when it comes to relating subcategory to subcategory, this is where we end up in trouble because we have duplicates in both columns that the cardinality will have to be many to many. I'm going to switch the cross filter for now to say that it always propagates filters from the dimension to the fact. That means from product to sale target. And so what we now have is a many-to-many cardinality between product and sale target. Remember, many-to-many means there's a weak relationship in the model. So therefore, we must be careful that we have subcategories that match on both sides. Otherwise, it will eliminate results at query time. Let's see how it works in a query. So what I'm going to do now is build up a table that shows monthly subcategory targets. And this is an okay visual because it's really just the fact data. Remember, it's monthly subcategory quantities. Yet, if I copy and paste this visual, and then I switch subcategory for product, what's going to happen? You know, anybody looking at this would go, oh, okay, in January, we need to sell 820, but look at January here. Look at the fact that it's repeating quantity because these products are basically reporting their subcategories quantity. Of interest to note, though, that the totals are correct. So Power BI is not doing anything wrong, but you have to think of it this way. That if we're grouping by coffee, as is the case here, all right, so we're going to filter this table for product is coffee. The subcategory is then used to filter this table, which is why we're getting the subcategory quantity, because there is no such thing in this model as product target. All right, so there's nothing wrong with this, but you just must be aware that it's open for easy misinterpretation. So what I might do in my model design is create a measure called target quantity that does something a little bit smart. All right, so this measure, as I'll paste it in, it actually tests what filters are being enforced. So I'm going to get rid of target quantity as a column, and I'm going to use the target quantity measure. And you'll see nothing comes back. I'll do the same for the other visual. And it does come back. Now the difference is this. The measure is testing, is the product column of the product table being filtered? If it's not, then it's okay to go ahead and sum the target quantities together. So then we get a blank result over here. All right, so you can force the use of measures so that some logic can be applied so as to avoid those situations where people will misinterpret the result. All right, so that's the concept of working with a many-to-many cardinality. Now the next topic is to talk about the filter direction. Do you see these arrows telling us that all of the relationships so far are propagating from the one side to the many side? Yet it is possible to propagate in both directions, that the many side can propagate backwards to the dimension side. And let me do this up here between sale and product. Okay, we've got many to many, and we'll do it here as well. But what we'll find is that Power BI Desktop says you can't do this because now we've got circular references of filter propagation that you just can't do it. So the recommendation is you shouldn't do it. But then why do we have this property? And the reason that we have this property, in my thinking anyway, is it's reserved for a very specific type of relationship. And at this stage, I'll remind you of our manager data. Do you remember that managers, their performance of sales is actually measured by the products that belong to one or more subcategories? What we really have here is a many-to-many arrangement, not to be confused with the many-to-many cardinality. This is used to solve the fact that we don't have a one side, probably because the fact table is at a higher level of granularity than the dimension table. What we have in this situation is that our managers and products have a many-to-many arrangement. And the way that we solve that is by introducing an intermediary table. So what I'm going to do is reference raw manager to create another table that will be called manager subcategory. And what I want in this table is 2 columns, the manager key and the subcategory, and 1 row for each relationship between a manager and subcategory. And this is how I can do it. First of all, merge queries back to manager. And the purpose of this is that I need to look up the manager key. There's the manager key. And then I can get rid of all of these columns. And then I have subcategory here, but this delimited value won't work for us. We need 1 row per subcategory. So there's an easy fix. I can go ahead and unpivot. I can split by delimiter. Where is it? Split column by delimiter that is semicolon. And for each occurrence, because there could be 2, 3, 4, 5, who knows? And under advanced options, I want it to split into rows. And look at the result here. For each manager, now I've got the subcategory, and we see that manager key 2 has 2 subcategories. Let me go ahead and add that to the model. I'm just going to save everything because I don't want that to crash. And now I can create these relationships. And it says you will need a many-to-many here, and we understand that. Let's filter from the dimension to the fact. The reason for this many-to-many cardinality is that this is a higher level granularity. Okay, there's no one side on the dimension that we can use. And then manager key to manager key. All right, so what does this mean now if I create a visual that says, for a manager, what was their sales? And we can see the result here is that Angus is 11 and B is 4. But the question is, how is the sale being summarized? And if we look at this, there's a one-to-many relationship here that is propagating, but there's a one-to-many propagating to here, but not here. Otherwise, it would propagate through. So there's no ambiguity because of this. But what if I made this both direction? Theoretically, it shouldn't allow that, but it did. Propagation happens from here to here to here, but also from here to here. Now, the result hasn't changed. Angus is 11 and B is 4. But what if I did this? I manage relationships and I make the relationship between sale and manager inactive. Watch the numbers. Angus is now 5 and B is 15. What I've just done is I forced the propagation to take this path. Now, Power BI Desktop shouldn't allow it. There should only be one active path between any 2 tables in the model, but because this relationship is so distant, it didn't test for it. What it means is that Power BI is likely to evaluate the relationship that is the fewest hops. But of course, we should never rely on this. Okay, so what I'm going to do is make this active again and show you how I would solve this problem. You see, the reality is that the manager means 2 things. It's a role-playing dimension. Manager can mean the manager responsible for a sale, or it can mean the manager for sales performance reasons that is responsible for one or more subcategories. And at the moment, it's sort of ambiguous in the way that our model's working. So what I could do is this. I could use DAX, and I could use a function like this. From a sales performance point of view, let's create a measure. And the measure simply says to calculate the sum of sales, but by using the cross-filter function, we're able to disable that the relationship between manager and sale is off for the purpose of this relationship and see how we get the result that we need. But there's another way we could solve this, and I like the idea of deleting this relationship. Now, when I delete that relationship, you'll see that filter propagation isn't happening anymore, and we're just getting the grand total for their sales performance. But we have a function called treatAs, and treatAs can be used to create a virtual relationship. So in this case, what I'll do is modify that measure to use my improved version of the function, which says this. Using treatAs, whatever the filters are applied to the manager key column of the manager table, then propagate them to the manager key column of the manager subcategory table. At the same time, use the cross filter function to turn off that relationship between manager and sale. Yes, it's getting complex, but we're solving a complex problem, is that manager is role playing, and that we can use DAX functions to enable, disable the properties of relationships, or indeed create a virtual relationship in this case, up to here at calculation time. Alrighty, so the last thing I want to do in this demo is a bit of cleanup. I want to hide this intermediary table. I want to hide columns that are used as keys. And therefore, in my fact tables, all those dimension keys, the many side columns, can all be hidden. And in the much improved model, then what the user is going to see is a fields pane that is really quite simple, with tables that represent the different business entities, no superfluous columns that are typically used for relationships, and calculations that provide the correct results. That's my definition of good modeling. So I'd like to wrap up with some good practices for you as a takeaway. When it comes to modeling, strive for applicable star schema design practices. Think about your tables playing the role of either a dimension or a fact, preferably not both at the same time. Learn about concepts like surrogate keys, snowflake dimensions, role-playing dimensions like date and ship date, and manager for sales performance. Junk dimensions I haven't covered, but read about them. They're a way of consolidating lots of small dimension tables into a single dimension table. For table consolidation, probably avoid having one-to-one cardinality relationships in your model, like product and product list price. Far better to consolidate them and reduce the number of tables that your model needs. For active versus inactive relationships, remember only one active path between two tables in the model. Better, often, to create duplicate dimension tables and therefore have active paths, which supports the best flexibility in your model, that you can simultaneously filter by order date and ship date within the same visual. Otherwise, you're going to be using measures that use the use relationship function to activate an inactive relationship for that evaluation. When it comes to many-to-many relationships, this means two things. What it can mean is that you're using a many-to-many cardinality, where my sale target related to product but at a higher level than the product table. We don't have a one side. Or, as was the case with manager and subcategory, that there is a many-to-many between the entities themselves, in which case you must introduce what we call a factless fact table, and then create the one-to-many to many-to-one relationships, noting that this was perhaps the one time when we use bidirectional filtering to allow the propagation across from fact to dimension to get to the fact. Okay, so it's probably the one time I would consider using it. So to my point about bidirectional, yes, you can do this, but turning it on can create confusion in the model. It can create incorrect calculations. It certainly can impact on performance because it requires more filtering effort. So therefore, only really enable bidirectional filtering if you've got that many-to-many between two entities. Now, a quick word on data integrity. What does it mean then if I have a product that doesn't exist? Let me sell one more thing for a product that we don't have. If I save that and come back and refresh my sale data. And this time, instead of month, I'm going to put category. The blank here, this is table expansion with the blank row added to the product table saying, yes, but for unknown category, we've sold $9.90. So this is an interesting one. Certainly integrity issues should be resolved. You'd want to be very careful if this was a weak relationship because it would eliminate from the query result, thereby understating your sales. All right, so that's what the blank is telling us. It's interesting to note that what would happen if ship date was blank and then I refresh this data. That's not a data integrity issue. In fact, if the many side is blank, then in this instance, it means it hasn't yet been shipped. So just be careful on how you express that to your users. All right, that's not working because I haven't got a ship date table anymore because I lost it, okay? But we would have seen a blank there. So blanks on the many side, okay. Blanks on the one side, not okay. And mismatches, not okay. All right, so the point about data integrity violation is that you may see them as blanks if they are strong relationships. So where possible, fix the quality of your data. Use Power Query to repair issues. A couple of words before I wrap up on theory. So direct query models, the only slight difference here is that you've got a property called the assume referential integrity. And as I described earlier, this will use more efficient inner joins, but make sure that you have referential integrity in place. Otherwise, those inner joins will be removing rows that don't match on the join condition. There's also a DAX function named combine values that does allow you to achieve multi-column relationships, not in the model itself, all right, but in your source data, that when it constructs the query that is sent to the source data, it can achieve multi-column joins. Have a read of the documentation on how that works. Lastly, for composite models, the only difference to bear in mind here is that many-to-many cardinality type relationships and cross-island relationships are weak, and therefore be very, very careful about data integrity issues and address them. Otherwise, you might be producing incorrect results in your model. Well, I've got to the end. I know this is a bit longer than I'd planned. For those of us that have stuck it out, now's a great time, if you've got any questions, to ask them.
Yeah, if you have questions, you can either unmute or you can enter them. Okay, Elena Schott has one question. Which more efficient, generate data table in M or in DAX, or doesn't matter?
Oh, which is more efficient? Okay, so generally,
she says date. I mean, she said date table.
For the date.
Not data. I misspoke.
So for data or for date?
So sorry. So I'll reread it correctly this time. I hope. Which more efficient, generate date table in M or in DAX, or doesn't matter?
Okay. It doesn't really matter because it's a dimension table, and let's just say you have 10 years of data. That's 3,650 odd records. That is not a lot of data that we're concerned with. But what would come down to is you would choose the tool that makes best sense for you, that either does it more elegantly or your skills are better matched for it. Okay, so my answer would be on that case, doesn't matter. But if data volumes did matter, Power Query would be a better choice, because calculated tables and columns are stored structurally slightly differently and less efficiently than columns loaded directly from Power Query.
Okay, other questions, people? Either you can unmute or you can put it in the chat. In the meantime, Peter, 90-minute presentation, only 2 people dropped off, and they were both in the last 15 minutes. So lots of interest. That's excellent.
Well, let me wrap up because I've just got some marketing slides. I'm just going to whiz through these. If you're in Melbourne or you want to drag me to San Francisco, feel free to check out the training that I have at my company. From a resources point of view, I build out guidance documentation for Microsoft. So a lot of this knowledge has been well written in articles that you'll find here. So the guidance articles at Power BI Docs, of which you'll find there are articles that talk about all of those different topics: one-to-one, many-to-many, active, inactive, bidirectional, and even relationship troubleshooting. So please check out the up-to-date knowledge there. Strongly recommend you check out the Data Warehouse Toolkit on dimensional modeling. If you're new to Star Schema, it's well worth becoming acquainted with it to produce good quality, optimal Power BI models. Alberto, that presented yesterday at your user group, has got a great video too that goes into deeper discussion on DAX and relationships. So that's well worth a watch as well. And otherwise, this is where I can wrap up by sharing with you the QR code or this URL that allows you to download the PDF of the presentation, which is a great resource in itself, talking about how to understand and optimize your model relationships. Well, Mark, that brings me to an end on my side.
Okay, well, Peter, thanks so much.